So let's start off with a little bit of an exercise on the audio response software. And not yet, as soon as everybody ready? So I'm going to hit, okay, now respond, 1 through 4. Yeah, click once, whatever your last click was is your last answer. If you change your mind, that's okay. Woo. No consultants. They should know this anyway. Business owner, industry rep. Okay, that's good to know. This is actually very beneficial for the business owners and representatives. This is really more targeted to you than it is inspectors. The idea is for the regulators and inspectors to understand what you should do. Okay, now the next one, we'll try one more. See if you can speed read. Very good. This should be an interesting class. There might be a couple out there in the audience that know more than I do. Consider doing this class next year. I would like to be listening and learning something. Yeah. Okay, we're going to talk about sampling. One thing I'm going to talk about, and for those of you in the industry and for the inspectors, you're going to see this. I've always had the DAs, enforcement people, worry about what I'm doing here, and so they vet this too. But inspectors typically do what we're called authoritative or enforcement sampling. And then a waste analysis plan is a document. If you're involved in something, you're required to have a waste analysis plan in some circumstances. We'll talk about it. And then the primary thing we're going to talk about is representative, simple, random sampling, and I'll briefly talk about stratified random and systematic random sampling. But once you get the simple random, those other two make complete sense. There's very little nuance to those. But start off with, and we've got to remember this, the generator makes the waste determination. That's the person whose actual process first causes a hazardous waste becomes subject to regulation. And of course, and then they're required to comply with Chapter 12. An inspector is not a generator. Now, I know that all of you in here are very experienced superb inspectors, but sometimes I have to remind our guys and say, we don't make the waste determination. Obviously, our inspectors know a lot, and it's okay to advise a business and work with them, but you've got to be very careful. We're not their consultant. We're not their expert, although some things are like used oil, it's used oil, not a lot of debate there, but I'm okay with helping and everything to say, it's not our responsibility, and we've got to be careful not to do that. Now, our data quality objectives, what I'm looking for from a regulatory prospect, are quite a bit different than what a business would necessarily be looking for, or what a storage, treatment, or disposal facility would be looking for the waste too. And this is from a US EPA guidance document that is still in draft. I would look at that the other day and said, 10 years in regulatory process? I wonder if this is ever going to become final. I'm beginning to question that. But we talk about the data quality objectives. For the inspectors out there, when you're sampling something, you're looking for an exceedance of the threshold, of the regulatory threshold. For business, your data quality objective is different than that, and that's what this is about. So, does an inspector have to take a representative sample? Correct, for most of you. And for the rest of you, by the end of this hour, you should understand that. Can the inspector's data quality objective be different than the facilities? It's the waste generator. Oh, I did it, I'm sorry. Here we go. Oh, great, almost everybody was paying attention. I'm trying to think of funny and not insulting for the, no, I'll move on, I think is the best maneuver here. So, again, I want to emphasize that waste determination is the generator's responsibility, not the inspector's. Okay. In Chapter 11 of Title 22 specifies two ways. Testing, you can do a waste determination by testing or knowledge of process. And we'll talk a lot about those. And it's called waste analysis. And this, again, comes from a US EPA guidance document. But for well-managed facilities, you can understand that they'll understand what's the waste, what could be a hazardous waste, and they recognize that and have a process in place to identify and make that determination. And when we talk about if we're doing laboratory analysis, we do it of a representative sample. But in some cases, we can use knowledge of process. That's a Office of Solid Waste and Emergency Response Waste Analysis Plan Guidance document at the bottom, the link to that. They recently changed their name, and I don't recall what it is very recently. The Office of Solid Waste and Emergency Response at US EPA. I should have changed that, but I neglected to. They very recently changed their name. I'd like to keep you confused. Come on in. No? Smart woman. Okay. Land disposal restrictions are difficult and hard to understand. I once gave a class here at the conference on land disposal restrictions, and I think important, actually. They're really a very important part of the hazardous waste program, but they're difficult to understand. And this is my first shot at it. And I started off with 126 people, and 2 hours later I had 8. And so I think I'm still working on this, but in San Diego, if I'm getting mad with the guys and want to torture them, I give them a class on land disposal restrictions. But you've got to do waste analysis if you're going to just say your waste can go to land disposal. So what you're going to see in the real world, and you're out there, you'll see a LDR, land disposal. It's going to say this is prohibited from land disposal because it contains the following. And you're going to look at this list and say, they've listed everything possible. And that's exactly what they do, so that they don't have to go into the waste analysis. And that's an acceptable LDR. It's prohibited from land disposal. Push the responsibility back to the treatment, storage, and disposal facility. But if they're doing that, they have to have a waste analysis plan. TSDFs have to have one. If you're treating under permit by rule, you have to have a waste analysis plan. And if a generator is treating their waste to say that it can go to land disposal, then they have to have a waste analysis plan. Now, when we talk about data quality objectives to determine if you can dispose of a waste, we're looking at an 80% confidence interval. That's one of the things that US EPA has decided. We want to be 8 out of 10 are going to go, and we're going to take, and it's going to be of representative samples. And you'll look, and when we talk about Article 3 of Chapter 11 of Title 22, where it lists the characteristics of a hazardous waste, and it's going to say that typically you're going to use SW 846. It allows for other references for this, but the reality is everything points to SW 846, and that's what everybody uses. And then when we talk about a ignitable waste, a corrosive waste, a reactive waste, a toxic waste, that's all based on representative samples of that waste for wastes that exhibit a characteristic of that they're hazardous because they exhibit one of those characteristics. This is right out of Chapter 10, the definitions. Representative samples, a sample of that represents the universe, and it exhibits the properties of the whole. And that's the title of Waste SW 846, and the Office of Solid Waste Compendium of Approved Analytical and Sampling Methods. It's a guidance document, and it's been around now. It's been evolved. I don't know, but I don't think it's really changed for the last 20 years. So it's pretty much the accepted standard. How do you find it? Well, this is a web page, a link to it, and the link's at the bottom of the page if you want. It's I don't know how well, yeah, you can see that pretty well, better than I can on this screen. It's chapter after chapter when you talk about all these test methods, and it's not entirely unrealistic, because for one very difficult enforcement case we did, I had Sandy drilling down into, well, what's the protocol for this? What size sampling, what filtrate, what size filter do they use to, with the solids in this for the samples? And it worked very much to our favor. Now, Chapter 9, I'm sorry, is there a question?
We were just talking a second, and I was wondering, SW 846 is an EPA document that mainly refers to RCRA, but how about non-RCRA? Is there...
Yeah, I understand that I think the question is that SW 846 is used for hazardous waste, really?
Right, but it specifically says for RCRA waste. What about non-RCRA?
Oh, for California, definitely. It's definitely the accepted standard for non-RCRA hazardous waste, too.
There's nothing else for non-RCRA waste other than the SW 846?
Yeah, and there's different test methodologies that you'll use, but you can find them in SW 846 for non-RCRA hazardous waste. In other words, what we're talking about is you could prepare a sample for testing, might be one test method, like California uses the WET, the waste.
Right, that's not in, that's not in the SW 846, the wet test.
Right, yeah. The WET's not in SW 846, it's in Title 22, yeah. The waste extraction test. And then SW 846 uses EPA method 1311, which is also called the TCLP, Toxicity Characteristics Leaching Procedure. And you can, the regulations give a facility the option of using other approved methodologies, but if you choose to do that, it puts you in a position of kind of developing your own standard, and then makes you have to defend that standard. So I would recommend, that's what all the analytical laboratories in the state uses, SW 846, so I would recommend sticking to that standard. Now, and I'm not quite there yet, but that would, if you're using some other test methodology, that would be very useful in knowledge of process, because that's giving you information about the waste, which is, of course, valid. Now, SW 846 makes some, and not always true assumptions, but the concentration of contaminant in an individual sample will be a normal distribution, and that simple random sampling is the most appropriate sampling strategy. But the more you learn about the waste, and Now I'm going to flip on the regulated facilities side. They know what materials they use. They know what goes in. They've got a good idea of what the contaminants are. They will always, or they should always know more about their waste than we do. So you have, they're continually, every day in their day-to-day operations, they're gathering information about their waste, and we have to respect that and listen to that. And that's all good applicable knowledge. But what we do to, if you're a facility, regulated facility, you use all that knowledge, but then you say, well, I'm going to verify it. I'm going to run an experiment. I'm going to sample and verify that make sure my assumptions are correct. Okay, so what we've got here, what we handed out into candy bags was a known population. And then I went on website and got some random numbers. And so I'm just going to walk through the class and count them off, and then those will be our representative samples. And we're going to do what we call plotting a histograph, and then compare the actual candy population with the sample population. For the guy who just walked in, don't give him any candy. He used to be my boss. What happens, Andy?
Oh, okay, we're good.
Oh, I pushed the wrong button. I pushed the button that turns it off. Okay, now what we've got, we packed 90 bags. When we first started doing this, we've been doing this course for 8, 10 years, I don't know, a long time. We get more crowds, we're getting more and more people do it, and fewer and fewer new inspectors to do it. So 10 bags contain 0 pieces of chocolate. 20 bags contain 1. 30 bags contain 2, etc. That's a known population. We know exactly what it was, although Susan Hahn, who helped Sandy pack the bags, warned me that they were talking and not paying attention. So, but you know, but in theory it should be, the average, the mean should be 2. Okay, if it was a perfectly homogeneous population, all the bags would have the same amount of candy in them, right? In the same type. So is this candy population non-homogeneous? Oh, come on, 3 of you, get in there. Yeah, if it was homogeneous, all the bags would be exactly the same. But it's kind of a negative, double negative, so that probably trapped a few of you with the question, you know? So yeah, it's a heterogeneous distribution. But let's get on to the random number. Okay, so this is a histograph and of the pops. You know, the candy is clearly a normal distribution. It's a known population. We know exactly what it is. Oh, let me just point out something. I want to go backwards. Over here, and I don't, but look at the left-hand side. Can you have, some of this curve goes into negative numbers. Can you have a negative amount of candy in the bag? I don't think that's physically possible. Maybe in a different universe, but not in ours, okay? So, but that's actually an important point, and we'll get to later. But you can't, you know, it's just like contaminants. You can't have a negative amount of copper or lead or nickel or zinc in a sample. You can't have negative amount of candy. Okay, so Sandy, I'll need some help here, but so I'm going to start with you, sir. That's 1, 2, 3, 4, 5. Your first bag of candy. How many pieces of chocolate's in it? No, the woman in white, the white sweater.
Oh, how many pieces of chocolate in your bags?
In the bags together?
No, just the first one. And I don't, you know, the one you picked up first is the first one.
2.
2. Oh, so that's the population mean. Okay, so your next bag is number 6. Now I've got to count all the way up to 18. 8, 10, 12. Probably go 14, 16, 18. Yeah. So your second bag has how many pieces of candy?
That's how many pieces of chocolate, right?
Pieces of chocolate, I'm sorry. 4. Okay. So we've got 1, 2, and 1, 4 so far. The point being, right now we've got, looks like the sample means 3, right? Based on 2 samples. On the first sample, that's all we needed to take. But that doesn't, but the one, it really doesn't tell us anything. It could have been 0, it could have been 4, it could have been 5. So, but now the tricky part, you're number 18, so I think you're 20. And you would be, your first bag, be 21.
How many pieces of chocolate?
3. So we got 2, 3, and 3. Right now, 2, 4, and 3. It's looking like 3, huh? Okay, so you're 22, you're 24, 26, 28, 30, 32. 1? 4. You keeping track? I'm having enough problems counting. So 32, 34, 36, 38, 40, 42, 44. Yes, sir, you, sir. How many pieces of candy do you have in your bag? 1. Okay, Sandy.
How many? 1?
Yes.
Okay. So we got 1 with 2, 1 with 4, 1 with 3, 1 with 4, and 1 with 1.
Okay, so if we look at that, we've got 1 and a 1. How many in a 2?
1 with 2,
How-
1 with 3,
1 with 3?
and 1 with 4. 2 with 4.
2 with 4. Okay, so add that up. And divide by 5. So yeah, it's 3. So what that's going to do, if I can get this thing to advance. Okay, will taking more samples increase the precision, the estimate of the entire population? Yes, absolutely. The more samples, the perfect way is you take sample all night, you take 90 samples for this 90 bag sample and you know exactly what you have. So, but that's the idea. That's what I'm trying to demonstrate with this little candy, to give you, a good sense of why one sample tells you absolutely nothing. Yes, sir.
You started by saying that a regulator only has to take 1 sample, which tells you absolutely nothing.
And I'm going to get to that.
As your slides go, I'm going to go ahead and advance it from there with the beat. You can, as you advance, I'll synchronize it with the beat.
Okay, so you'll be back there and I can go and just do it on my own rate though?
Yes.
Oh, cool. I don't have to. Yeah, and I'm going to do that. Now, it's important if you're on the witness stand as an inspector. Oh, I'm sorry. The question was, is it says, and we're going to get to that, an inspector can take an authoritative sample, but I just said that one sample doesn't tell you anything. So it's important, and we'll get to this when you're in later on, but you need to walk out of here comfortable on the witness stand to be able to explain why your one sample as a experienced expert inspector demonstrates that they exceeded a hazardous waste threshold versus the facility's obligation to get a representative sample. And of course, if the facility has a good sampling plan and does a representative sample, then if I was the judge or jury, I'd vote for the facility and not the inspector because they have more information. But typically a facility that has that kind of a program in place doesn't have any problems at all. Yeah. It's just reality of it. So, we're going to talk a little bit about the rest of it. That's the concepts. If you got that, you've got the concept. Now we're going to talk a little bit more about normal distribution, some terminologies, and then do some math, just how to do it in a little bit more terminology. But I think we really covered the Chapter 9 of SW 846 pretty well in an hour. And some of the clickers, if you fall asleep, are programmed to shock you. So a normal distribution is a bell-shaped curve. And the true population lies under the curve of a normal distribution. In a perfect world, of course, all the samples are going to be in that normal distribution. Now, in this case, we're showing it worked out. The sample population's a little bit smaller. It's showing a population that's smaller than the real distribution, but it's doing a very good job of replicating the actual population, and that's what we strive for. So we need reliable information. And to be reliable, it must be accurate and sufficiently precise. Accuracy is no bias, and usually it's obtained by having a truly random sampling. And precision is a function of the number of samples you take. Make sense? Now, another factor that we don't always think about sample size, but small samples you can miss, but a large sample you're more likely to represent it, of course, and they homogenize it at the lab and take another sample, though, which could introduce, but Patty knows, Patty in the room? She's here for the next session. She knows a lot. That's what she does for a living every day. So if you want to talk to somebody about that, she's the person to talk to. But sometimes, in some cases, I've been on enforcement cases where you sample literally everything you can get. The residue going into a storm drain, what's lying in the bottom, that sort of thing. So you can only take one sample. You can sample everything. But you can see the difference in the size of the sample, just a little bit of a different concept. So precise means that the samples are similar. And you increase precision by taking larger samples or more samples. Accurate or unbiased is truly random. And inaccurate is synonymous with biased samples. Let's look at some. Now this would be an example of both biased and imprecise. Imprecise because they're spread all over the place. Biased because some are outside of the true population. When you miss the true population, by definition, it's biased. Somehow you introduce some kind of error for those biased samples. And imprecise have more variation, so unbiased but imprecise, they're still spread all over the place, but they're not biased. They fall into the population. And then to solve that problem, you take more samples, and then you get more precision with more samples. Now, precise and biased. You've got a good type group, right? You're really taking very precise samples, but somehow you introduce some bias into this, and they're not entirely inside the true population. And so what it does is give you a bad estimate of what the population looks like by shifting the normal distribution curve. And, there's all sorts of reasons for biased samples, but the really, if you're random, you have clean tools, you know, you're thinking through your process, you shouldn't introduce bias. But, and this is an example of precise samples, but they're not biased. So, you know, we talk a lot about consistency in the CUPA world, but I say it's only a virtue if you do it right. You know, so, oh, come on, you guys. I thought this. Set all the clickers to stun, and let's, you know. So, unbiased and precise is a function of randomness, and you've got enough to where you're getting a good idea. Okay? Maybe it's.
I have a question.
Yes.
Just in applying this in a real world application, say you're out in the field, say like a mine, a big quarry, and one of the huge pieces of mining equipment had a hydraulic, there's a line broken, slot, you have all this really concentrated hydrocarbon. Now, the person who ran this facility went in and took a sample, right, slot, right where he saw that hydrocarbon, versus digging up the dirt, putting it in a pile, and doing what I would consider more random sampling, which could be the, one, you know this is the concentration of spill, but it's not really representing the dirt that you're now going to take off-site and you're determining hazardous.
So, and it really wasn't a question, or I think there's an implied question there. It's a comment.
It's either more
Yeah.
appropriate way of sampling.
If we're talking about sounds like something I would do as an inspector, I'm going to go in and take the sample from the place I expect to exceed the regulatory threshold. So I can say, this is hazardous waste, you must manage it as such. But you're going to excavate an entire pile of waste. And you're saying, does that pile of dirt in and of itself, just because the one sample I took to prove you're exceeding that regulatory threshold, does that really in fact demonstrate that your entire pile of waste exceeds the regulatory threshold? And the answer is no. I don't know, if you dig up enough dirt, your pile is not going to be hazardous, you know, which is another discussion on dilution and the whole subject matter. But let's go through this conceptually. It's a good, I understand what you're saying, and I understand that you have different data quality. I would have a different data quality objectives than you. I want to prove it's one sample has exceedance, and I want you to manage it as hazardous waste. But you're saying when I do this, is my entire waste a hazardous? So two different data quality objectives. So there's nothing wrong with either approach. What SW 846